Welcome to MRL. In this learning session, we'll be learning the solutions of the examples of exercise 2.3 of the Polynomials chapter of 9th NCERT textbook of 25-26 textbook of mathematics, and now being used by different state boards. Now let us begin with the exercise 2.3. The first example. Now to determine the polynomial which has x plus 1 as a factor, we are given different polynomials. Now we have to find out whether x plus 1 is a factor of those polynomials. Now the first example is, now we are given a polynomial p of x is equal to x cube plus x square plus x plus 1, and we are given the binomial x plus 1, and I have taken it as g of x. Now we have to find out whether x plus 1 is a factor of the given polynomial p of x. Now if x plus 1 is a factor of p of x, then the 0 of x plus 1, that is minus 1, if I put wherever x is there, if I put minus 1, that means if I find p of minus 1, and if p of minus 1 is 0, the value of this polynomial becomes 0, then x plus 1 is a factor of p of x. Now please remember this, that in this these examples we are using both the remainder theorem and the factor theorem to prove that a given binomial is a factor of the given polynomial. Now let us go to find the p of minus 1. Now p of x is equal to x cube plus x square plus x plus 1. P of minus 1 will be putting x as minus 1 cube plus minus 1 square plus minus 1 plus 1. Simplifying, we get 0. So we have found out here that p of minus 1 equal to 0, and therefore x plus 1 is definitely a factor of the given polynomial p of x. So please understand that. Now the second example is x raised to 4 plus x cube plus x square plus x plus 1 is the polynomial given. Again x plus 1, we have to find out whether x plus 1 is a factor of this polynomial or not. Now the 0 of the polynomial x plus 1, which is a binomial, is x minus 1, and therefore find out p of minus 1, and if p of minus 1 equal to 0, then x plus 1 is a factor. So that is how we have to find it out. Now let us find out p of minus 1 first. Now wherever x is there, put minus 1 raised to 4 plus minus 1 raised to 3 plus minus 1 raised to 2 plus of minus 1 plus 1. Simplifying this, we get p of minus 1 as 1. Here p of minus 1 is not equal to 0, and definitely x plus 1 is not a factor of the given polynomial. Now let us proceed further. That is the third example. Now we are given here the polynomial x raised to 4 plus 3x cube plus 3x square plus x plus 1. Now we have to find out whether x plus 1 is a factor of this. Again the same procedure. The 0 of x plus 1 is minus 1, and therefore p of minus 1 equal to 0. If I put the values of minus 1 here, and if I get p of minus 1 as 0, definitely x plus 1 is a factor. So let us find out p of minus 1. Now putting the value of x as minus 1 everywhere, we get p of minus 1 as 1, which is not equal to 0. Therefore x plus 1 is definitely not a factor of p of x. Now next example, we are given p of x is equal to x cube minus x square minus 2 plus root 2 in the bracket into x plus root 2. X plus 1, we have to find out whether x plus 1 is a factor of the polynomial. So the 0 of x plus 1 is minus 1, and therefore finding out p of minus 1, we have to show that it is 0. If it comes 0, then x plus 1 is a factor. But when I find out p of minus 1 there, putting the value of x in the given polynomial, I find the p of minus 1 is 2 root 2 and not equal to 0. Therefore x plus 1 is definitely not a factor of p of x. So very simple, but understand the method of solving the example. Now the next example is to find if g of x is a factor of p of x. Again the same procedure. We are given a polynomial p of x is equal to 2x cube plus x square minus 2x minus 1, and we are given another binomial g of x is equal to x plus 1. We have to find out whether g of x is a factor of p of x, and for that find the 0 of g of x first. The 0 of g of x is minus 1, and therefore putting minus 1 in p of x. So p of minus 1 we find, and if p of minus 1 becomes 0, definitely g of x is a factor, and I have found out here p of minus 1, and it is equal to 0, and therefore definitely g of x or x plus 1 is a factor of p of x, and that is the correct answer. Now second example here, we are given a polynomial p of x is equal to x cube plus 3x square plus 3x plus 1. Again g of x is given as x plus 2, which is a binomial. The 0 of x plus 2 is minus 2, and therefore if I find p of minus 2, and if it comes 0, then x plus 2 is a factor of the given polynomial p of x. Now let us find out p of minus 2 first. So p of minus 2 is equal to, putting x as minus 2, I get minus 2 cube plus 3 times minus 2 square plus 3 times minus 2 plus 1. Simplifying, I get minus 1. That means p of minus 2 is not equal to 0, and therefore gx or x plus 2 is definitely not a factor of the given polynomial p of x. Now please remember this. Now you have to know how to apply the remainder theorem and the factor theorem in solving these examples. So please, I have made a note here. Gx will be a factor. Please understand, g of x will be a factor if the remainder is 0. That means if I divide p of x by g of x, the remainder should come 0. That is, rx must be equal to 0 for g of x to be a factor of p of x, and this remainder can be found out by remainder theorem, and if the remainder comes 0, definitely by factor theorem that will be the factor of the given polynomial. Please understand that. Now coming to the next example, that is p of x is given as x cube minus 4x square plus x plus 6, gx is x minus 3, binomial x minus 3, the 0 of x minus 3 is 3, and finding out p of 3, we find 3 cube minus 4 cube square plus 3 plus 6, and we find that p of 3 equal to 0. Because p of 3 equal to 0, that means gx x minus 3 is a factor of p of x, and it is correct answer. Now the next example is, that is example number 3, to find value of k. To find value of k if x minus 1 is a factor of the given polynomial. Now the polynomial given here is x square plus x plus k, and gx is x minus 1. The 0 of g of x is x is equal to 1. Now finding out p of 1, and if p of 1 equal to 0, you please understand this very carefully, that p of 1, if it is equal to 0, okay, please understand, p of 1 will be equal to 0, because they have said that x minus 1 is a factor. If x minus 1 is a factor, then p of 1 must be equal to 0. Therefore x square plus x plus k can be equated to 0 by putting the value of x as 1. So therefore 1 square plus 1 plus k equal to 0, or 1 plus 1 plus k equal to 0, 2 plus k equal to 0, and k is equal to minus 2. So please try to understand this example is slightly different. Now here he is already telling that x minus 1 is a factor of the given polynomial. If x minus 1 is a factor of the given polynomial, then when I put x is equal to 1 in this polynomial, then the value of the polynomial has to become 0, or x square plus x plus k must be equal to 0. So by equating it to 0, by simplifying it, I get k is equal to minus 2, and that is the method. Now coming to the next example, we are given p of x is equal to 2x square plus kx plus root 2. Now gx is given as x minus 1, and x minus 1 is also a factor of this. If x minus 1 is a factor, then the 0 of x minus 1 is 1. If I put x as 1 here, then it will become 0, because x minus 1 is a factor, but natural. By putting the x as 1, this should become 0. Therefore equating 2x square plus kx plus root 2, by putting the value of x as 1 equate to 0, then we get 2 plus x plus root 2 equal to 0, or k is equal to minus root 2 minus 2, or minus 2 plus root 2 is the value of k. So please understand this method. Now x minus 1 is a factor of this given polynomial. If x minus 1 is a factor of this polynomial, then the 0 of x minus 1 is 1. If I find out p of 1, then the value of this polynomial must be 0. So now I can equate this polynomial to 0 and find the value of k, and I found out to be minus 2 plus root 2, and that is the value of k. Now coming to the next example, we are given here p of x is equal to kx square minus root 2x plus 1. Again x minus 1 is a factor of this polynomial, and the 0 of x minus 1 is 1. That means if x minus 1 is a factor, p of 1 must be equal to 0, or kx square minus root 2x plus 1 must be equal to 0 when x is 1. So by putting the value of x is equal to 1 and equating to 0, I get k minus root 2 plus 1 equal to 0, or k is equal to minus 1 plus root 2, or k is root 2 minus 1. The next example is p of x is equal to kx square minus 3x plus k, and gx is x minus 1, and x minus 1 is a factor of the given polynomial, and that means when I put x is equal to 1 in this, the polynomial should be 0. Therefore kx square minus 3x plus k, when I put x is equal to 1, k1 square minus 3 plus k equal to 0, k minus 3 plus k equal to 0, or 2k is equal to 3, or k is equal to 3 upon 2. Remember that. Now coming to the next important example, that example number 4, that is factorization. Already you know what is factorization. So factorization is the process of expressing a given algebraic expression as a product of two or more algebraic expressions, and we know that factorization can be done by different methods, and here I have adopted the middle term splitting method. Now let us take the first example, 12x square minus 7x plus 1. Now I can split, you know how to split, you already learned how to split the middle term. Now when I add minus 4 minus 3, I get minus 7. When I multiply, minus into minus is plus, 4 into 3 is 12, 12 into 1 is 12. Definitely the splitting is correct. And group them now. After splitting from 3 terms, I made it 4 terms, and then group them into pair of terms. That means 12x square minus 4x minus 3x plus 1, and take the HCF common. The HCF between 12 and 4 is 4. HCF between x square and x is x. So 4x in the bracket 3x minus 1, and here 1 is common. Take minus 1 outside, 3x minus 1. Again we have 3x minus 1 common, and therefore take 3x minus 1 in the bracket, and remaining is 4x minus 1. So these are the two factors of the given polynomial. Now the next example, 2x square plus 7x plus 3. Again you can go for splitting here. So when I multiply, I should get 6. When I add, I should get 7. So 2x square plus 6x plus x plus 3 is the correct splitting, because plus 6 plus 1 becomes plus 7x, and plus into plus is plus, and 6 into 1 is 6, and therefore it is the correct splitting. And pair them now, group and pair them rather. 2x square plus 6x plus x plus 3, and what is common in this? HCF is HCF of 2 and 6 is 2, HCF of x square and x is x, and therefore remaining is x plus 3. And here the common is 1, plus 1 in the bracket x plus 3. Common here again x plus 3 in the bracket 2x plus 1. Therefore the factors are x plus 3 and 2x plus 1, and that is how we factorize by a middle term splitting method. Now coming to the next example, 6x square plus 5x minus 6 is the polynomial given to us, and now 6 into 6 is 36. With a minus sign, therefore I should get minus 36, and I should get plus 5 in the middle. Therefore by splitting it into 9x and minus 4x, let us understand here, plus 9 into minus 4, 9 into 4 is 36, so minus 36 is correct, plus 9 and minus 4 is plus 5, the splitting is correct. So therefore 6x square plus 9x minus 4x minus 6 are the 4 terms. From 3 terms we have made it, and then pairing them now, grouping them, and taking the HCF common. Now 6 and 9, 3 is common, x square x is common. In the bracket you get 2x plus 3. Please understand here, 3 into 2 is 6, x into x is x square, 3 into 3 is 9, 9x is there. So when I multiply or open the distributive, open this bracket, applying the distributive property, I should get back the previous step. Similarly here, the 2 is common, taking 2 outside, then remaining is 2x plus 3 multiply. Minus 2 into 2 is minus 4, x is correct, minus into plus is minus, 3 to the 6, and therefore I am getting the previous step. So therefore the procedure is correct. Now what is common in this? 2x plus 3 is common, take 2x plus 3, remaining is 3x minus 2. So please understand the method of middle term splitting method. It will be easy for you if you can solve them with the correct steps. Now 3x square minus x minus 4 is the polynomial given. We have to find out the factors. Now split it. Minus 4 plus 3 is minus 1. Minus 4 into plus is minus 4 into plus is minus 4 into 3 is 12. Therefore it is correct splitting. Now what is common in this? 3x square plus 3x, what is common? 3x is common, in the bracket x plus 1, minus 4 is common, bracket x plus 1, x minus x plus 1 is common, take x plus 1 outside. Therefore the factors are x plus 1 and 3x minus 4, and that is what is the method. Now coming to the next example, again factorization. Now here p of x is given as x cube minus 2x square minus x plus 2. Please understand here it is a cubic polynomial. So therefore here we cannot apply either the middle term splitting method, but now only the method what we can go for is the factors theorem method. So to apply the factors method, let us see what to do. Now I have written here, it is a cubic polynomial. We have to, not it is horse, it is have to. Please understand, this is corrected. If we have to use factor theorem to find at least one factor, then adopt middle term splitting method or find all other factors by factor theorem. So let us understand what is the statement, what is the meaning of the statement. Now before we go for the factor theorem, now what is the procedure? Now first of all, understand here 2 is the constant here. The factors of 2 are plus minus 1 and plus minus 2. Now actually this can be factorized by using the identity, that is x plus a into x plus b into x plus a is equal to x cube. So that is the identity to be used here, but we will not go for that. Just we will find, I will make it more easy for you. Take the factors of 2, find the factors of 2. The factors of 2 are plus minus 1 and plus minus 2. Now put the value of x as plus 1, minus 1, plus 2, minus 2, and find out which of them will give you the 0, the value of the 0, value of the polynomial as 0. Now let us start with 1. When I take x as 1, I get 0. If p of 1 becomes 0, 100% x minus 1 is a factor. Please understand here, because we know that if the remainder becomes 0 and then x minus 1 is a factor, that is by factor theorem. So here again we are applying the remainder theorem as well as the factor theorem. So therefore we have p of 1 equal to 0, therefore 1 0 of p of x is x is equal to 1, therefore one factor of p of x is x minus 1. So we have got one factor as x minus 1. Now we can go for the next p of minus 1. So go for p minus 1, find out, again we got 0. That means if p of minus 1 equal to 0, then second 0 of p of x is x is equal to minus 1. Therefore the second factor of p of x is x plus 1. Now find out p of 2. Again we got 0. Once p of 2 is 0, then third 0 of p of x is x is equal to 2. Therefore the third factor of p of x is x minus 2. So all the three factors are found out by using factor theorem here. So when p1 is 0, that means x1 is the 0. If x1 is the 0, x minus 1 is a factor. If p minus 1 equal to 0, then x is equal to minus 1, x is equal to minus 1. That means the second factor of p of x is x plus 1. If p2 is equal to 0, then x is equal to 2. That means x minus 2 is the third factor. So we have the factors as x minus 1, x plus 1 and x minus 2. So these are the three factors of the given cubic polynomial, and that's the procedure. Now let us go for one more example, that is factorize x cube minus 3x square minus 9x minus 5. Now take 5 here, write the factors of phi. The factors of phi are plus minus 1 plus minus phi. So now we have to go find out the value, which value of x will make the polynomial value of the polynomial 0. So let us start with 1. With p1 I didn't get 0, therefore that can be neglected, that can be given up. Now find out p of minus 1. We find that for p of minus 1 it is 0. The value of the polynomial becomes 0 when p is minus 1. Therefore 1 0 is x is equal to minus 1. Therefore one factor is x plus 1. So we have got one of the factors as x plus 1. So let us go for p of phi. Again for p of phi also I get 0. That means another 0 is x is equal to phi. Therefore the second factor is x minus phi. Now go for p of minus phi. It is not equal to 0. That means x plus phi is not a factor. Now we have to find the third factor. To find the third factor is very simple. Since I have already got the factor x plus 1 and I have got the factor as x minus phi, multiply x plus 1. That means I can divide the given polynomial by x minus phi. I can divide the given polynomial by x minus phi. When I divide the given polynomial by x minus phi, I get the quotient as x square plus 2x plus 1. Therefore the given polynomial, applying the the polynomial algorithm of division of polynomials, we get the dividend is equal to the divisor into quotient. So therefore x cube minus 3x square minus x minus 9x minus 5 is equal to x square plus 2x plus 1 in the bracket x minus 5. Now I have got x minus 1 as a factor here. Now this one I can go for middle term splitting method, or I can use the identity method. And if you observe here, x square plus 2x plus 1 is an expansion of x plus 1 whole raised to square, and therefore this can be written as x plus 1 whole raised to square in the bracket x minus 5. X minus 1 whole raised to square is nothing but x plus 1 into x plus 1 into x minus 5. So these are the three factors of the given polynomial. So let me just explain the procedure again. You are given a polynomial, find the factors of phi. The factors of phi are plus minus 1 plus minus phi. Now check for which value of x the polynomial becomes the value of the polynomial becomes 0. Then find out the factor. So we have got the factor as x plus 1 there. Then with phi also we got a factor as x minus phi. So we have got two factors, but the third factor is not obtained there. So what we will do is we will divide the polynomial by x minus phi. Since x minus phi is a factor of that, so when I divide the polynomial x minus by x minus phi, I get the remainder as 0. I get a quotient as x square plus 2x plus 1. Now by applying the polynomial algorithm of division of polynomials, we know that dividend is equal to divisor into quotient plus remainder. Remainder is 0 as it is. So therefore x cube minus 3x square minus 9x minus 5 is equal to x square plus 2x plus 1 in the bracket x minus 5. This is the quotient and this is the divisor. So dividend is equal to divisor into quotient into divisor plus remainder. Remainder is not there, so 0, leave it. And therefore x square plus 2x plus 1, we can go for identity method, find out the factor, that is x plus 1 whole raised to square into x minus 5, and x plus 1 whole raised to square is nothing but x plus 1 into x plus 1 into x minus 5. So for the factors are x plus 1, x plus 1 and x minus 5. These are the three factors of the given polynomial. Please remember that. Now coming to the one more example, and the example is x cube plus 13x square plus 32x plus 20. So this is a polynomial, cubic polynomial. Again we have to use factor theorem. Now let us find the factors of 20. The factors of 20 are plus minus 1, plus minus 2, plus minus 4, plus minus 5, plus minus 10. These are the factors. Now let us find out which one of the variable of x makes the value of the polynomial 0. Let us start with minus 1. If I take 1, it is of no use because all are positive values, nothing gets cancelled, so I have taken minus 1 first. So p of minus 1 I got it as 0. If p of minus 1 is 0, the value of the polynomial is 0 for the x is equal to minus 1, therefore x plus 1 is a factor of the given polynomial. So one factor I have got. As soon as I get one factor, what I did is straight away I divided the given polynomial by x plus 1. See, I have divided here x cube plus 13x square plus 32x plus 20 divided by x plus 1. I got the quotient as x square plus 12x plus 20. I believe that you all know how to carry out long division of polynomials. If you are not learned, please learn and understand the long division, because this is very important for you to learn. So now I have divided here by x plus 1. I got the quotient as x square plus 12x plus 20. Now applying the algorithm of long division of polynomials, I have written here that the dividend, that means the dividend is equal to the divisor into quotient, because remainder is 0. So dividend is equal to divisor into quotient, that is x plus 1 in the bracket x square plus 12x plus 20. Now it is a trinomial. I can go for middle term splitting method. By middle term splitting method, I get x square plus 10x plus 2x plus 20. It is correct splitting, because plus 10 plus 2 becomes plus 12, plus 10 into plus 2 becomes plus 20, and by grouping them, now pairing and grouping them, I get x is common here, x plus 10, 2 is common here, x plus 10, again common is x plus 10 into x plus 2. So therefore the two factors I get here as x plus 10 and x plus 2. One factor I have already got it as x plus 1. So x plus 1, x plus 10, x plus 2 are the three factors of the given cubic polynomial. So this is a very easy method, provided you know how to go for how to find the quotient by, how if you know the long division method of polynomials. Now coming to the next example, we are given here the polynomial 2y cube plus y square minus 2y cube plus y square minus 2y minus 1. Now let us find the zeros, and we for that we have to use the factor theorem. Now here, if you observe here, we have got 2 and 1. 2 and 1. 2 is the coefficient of y cube. The coefficient of y cube is not 1 here, it is 2, and the constant is 1. So the factors of we have to find out 1 divided by 2. So we have to find the factors of half here. The factors of half are plus minus 1 plus minus half. Now let us see which one of the variable of x gives us the value of the polynomial as 0. Now taking 1, since there are negative values, I can go for p of 1. So when I found out p of 1, I got the value of the polynomial as 0. We got the polynomial value as 0. That means if p1 is equal to 0, then y minus 1 is one factor. Y is equal to 1 is 1, 0. Therefore y minus 1 is one factor. Now I will straight away go for dividing the given polynomial by y minus 1. I get the quotient as 2y square plus 3y plus 1, and then I can go for the middle term splitting method and find out the factors of 2y square plus 3y plus 1, and that is exactly what I have done. So the dividend I have taken and I have multiplied by the divisor and the quotient, and then I have gone for middle term splitting method to find the factors of the quotient there, and I have found out the factors as y plus 1 and y plus half, and of course we can take 2 also common here, or else we can just keep it like that. So therefore the factors of the polynomial p of y are y minus 1, y plus 1 and 2y plus 1. So these are the factors. If you want, we can take 2 as common and change the 2y plus 1 as y plus half, and it's better you can keep it as y minus 1, y plus 1, 2y plus 1 are the factors of the given polynomial. That is how we factorize it. So therefore the factors of 2y cube plus y square minus 2y minus 1 are y minus 1, y plus 1 and 2y plus 1. So that is what is the procedure of carrying out the factorization of any given polynomial. Now in this particular exercise, the only important thing or slightly different is the factorization. So learn factorization, a very important part of our study, and especially the factorization of cubic polynomials using factor theorem and application of factor theorem to find the factors of the given cubic polynomial. So understand the procedure, practice them, and it will be easy for you. Okay, learn. If you have any suggestion, any comment to make, please do it, so that I can help you out in finding out further easier methods, or which will help you to understand the subject better. Okay, note down in a book so for your future reference. Thank you.